That was kind of a loud beep there. Again, so these days they feel like standalone lessons, and they could be standalone lessons, but we're trying to hopefully get to the point where they're not standalone, they're linked, and we understand the connection between them. Let's start with any questions from 273. Did a couple together yesterday. Are there questions from 13 to 31, Connor? I suspected that would be a question. Okay, let's briefly remind ourselves what this means. I don't expect any of you to have written this down, but just as a reminder, that symbol means area under y equals 1 minus absolute value of x from -1 to 1. So we want to graph it, draw it, and then see what shape we have, and go from there. Absolute value. You might remember that kind of gave us fits in the derivative section of things. We would usually just try to draw the picture and figure out what the problem was, or where the problem was. It's kind of the same thing here. This thing has the v, or the point, at x equals 0. That's where the absolute value is 0, so that's where it makes the turn either, don't know which way, well I do know which way because it's a minus sign, so it's going down. So I think the easiest way is to just do a table of values. You definitely want 0 in there because that's where the point is. And we're only going from -1 to 1. So if I plug in -1, I get 1 minus +1 is 0. I plug in 1, 1 minus 1 is 0. So -1, 0, 0, 1, 1, 0. And I know it's a V, so I don't have to worry about, how it's curved. It's not curved. It looks like that. So that's probably the hardest part of the problem, right? Getting the picture drawn. Now it's a triangle. Area is 1/2 base times height. So 1/2. I guess be careful because base is 2. And height is 1. And I suppose you could leave that as an answer if you really wanted to embrace the safe stop idea. But the area is 1. So absolute value, I'd say locate the point and then just plug in some points on either side to figure out what it looks like. Other questions from 273?
This isn't like a number question, but you'll never go under the x-axis. Like you stop as like you're stopping.
So yes, under the x-axis, no. There's a but coming that we haven't got to yet, but I may as well say it now. If let's see, that's 3. Let's make this -2. So if we wanted the integral from 0 to 3 of -2 dx, well, you can't go under -2. I mean, I guess you could, but it'd be under forever. So we kind of switch our thinking from under to the x-axis. So it would mean that area, which is 6, but there's something strange about that area, right? It's under the x-axis. What do you think? What do we usually do in math when something's like opposite or under or reversed? How do we handle that usually? Negative. And so, will we be under the x-axis? If we are, it just makes the area negative. So that's a really good question. We didn't hit that in that lesson, and I don't even know if that we hit it today, but we eventually get there. So it's a good question.
Can you also do 27?
27. Integral from 0 to 2, 3x plus 4 dx. So again, that's the area under that curve from 0 to 2. So if I plug in 0, I get 4. Slope is 3. Or I could just plug in, f of 0 is 4. I could just plug in 2, because I know it's going to be a straight line. F of 2 is 10. 5, 6, 7, 8, 9, 10. Right? I mean, I guess it goes through 1, 7, but I don't really care about that. I'm only concerned about 0 to 2. So it's a trapezoid. So that's base times the average of the heights. So one height is 4 and one height is 10. So that would be 14.
I did the calculation wrong.
Did the calculus right, but the calculations wrong. That's why we show our work. Anything else from 273?